In this question from the chapter application of derivatives, right, and that's based on maxima minima. It says a tank with rectangular base and rectangular side open at the top to be constructed so that its depth is 2 meter and volume is 8 meter. So depth is same as height. So I can take this, say, h as how much it is given as 2 meter, and the volume, and what's the volume of a cuboid? This is L into B into H, right? Or you may write like L into B into H is the volume, and that's 8. Well, we know H, so we can substitute H, so that will results to give you LB into 2 is equal to 8. So we got the product of L into B as how much? 4. So we got one relation over here. Later, if I read the question, it says that if the building of the tank costs rupees 70 per meter square for the base, this is for painting, for making the base, whatever the sheet or material needed, is rupees 70 per meter square and rupees 45 per square meter for the sides. So it's a lateral surface, right? Lateral surface area is to be made at the cost of rupees 45 per meter square. What we have to find out is the cost of the least expensive tag. That means we have to minimize the cost. So let's figure out the cost. Before that, I can take one of the variables, say L as X. That results to give you how much? B as B should give you 4 over X. Now how to get the cost over here? Since we are getting the cost in terms of X, let's write down C dash Cx as the cost function. And how do we calculate? Let's first calculate the cost for making the base, which is rupees 70 per meter square. And that is 70 multiplied by the base area, and base area is length into breadth. So I'll also write LB, L into B, plus now it comes to making the sides, and for sides it says lateral surface area at the rate of rupees 45, at the rate of 45. So what is the lateral surface area of a cube? It's 2h bracket L plus B, right? This is what the lateral surface area. So it's 2 multiplied by h, and how much is h? We have h as 2. So I can replace this with 2 times L plus B, and how much is L? L I have taken as x and B as 4 over x. Now what you can see from here, that we know actually the value of L into B, that is, from here we know that is 4. So let's plug in the value. Let's say this be Cx only. This is 70 multiplied by LB. LB is 4 over here, plus how much is this? 90 into 2, that is 180. Let this be as it is. To avoid the quotient rule, I did it like this only. Now this is Cx is equal to 74 into 2 is 28. So it should be 280 plus 180. And as I said, I'll keep it as it is. Next, we are going to find its differentiation. That will be, this is 0 plus this is 180. X differentiation is 1, and 1 by x differentiation is minus 1 over x square. One more time. Differentiation of 1 over x is what? Minus 1 over x square. And that's the reason I'll write differentiation of x as 1, and this is minus 4 over x square. Right, this is how we find its differentiation. And then what next is to, let's see if I erase these things. We won't need these things. Now we find its differentiation, and for maxima or minima, C dash x has to be equal to 0. C dash x has to be equal to 0. Equating this with 0, what I'll get over here, this will give you 180 times 1 minus 4 over x square is equal to 0. Right. So 180 on transposing will become 0. So it comes out to be 1 minus 4 over x square is equal to 0. So I may write this as 1 is equal to 4 over x square, and therefore x square is how much? 4, and x can be plus minus 2. As you know, x here is a dimension and it cannot be negative, so we will only take the positive value of x, that is x positive value. That's the positive value of x, which is 2, right, in that case. So we needed to find the dimension. So let's say I got x as positive 2. Now check here. If I find c double dash x, that means second order derivative, this is going to be 180. This will be 0, right? This is minus 4 is as it is. If I find the derivative of 1 over x squared, should I show it? This is actually x raised to the power minus 2, right? Considering this, whose derivative will be what? Minus 2x raised to the power minus 3. So actually it's minus 2 over x cube. So it's going to be minus 2 over x raised to the power 3 in the denominator. As you can see, we are getting what? A positive value. From here you can figure out that this is a positive value. That is 180 into 8 over x cube, x being positive. So therefore we can say that this second derivative is greater than 0. Therefore it is minima, right? Minima. So once we got x, now we have to find out what is the cost of least expensive tank. So next we are going to just replace this x over here, as we have already got the value over here. I can replace in any of these equation. Let's say if I replace the value of x over here, right? This is what the cost. So from here we can get the value. So let's say if I do it over here. So the cost, which is cx, is going to be replacing, taking x as what? 2, right? So this is, I'll place here, right? That's simpler to do. 280 plus 180, that multiplied by x, replacing x with 2, and this is 4 over 2, which is 2, right? Replacing x with 2. So this is 280 plus 180 multiplied by 4. So this is 280, and 18 into 4 is how much? 72. So it's 720. So if I add this number, this is 0, 7, 8 plus 2, 10, carrying 1, 7 plus 2, 9, 1, 10. That comes out to be 1000. So it should be in rupees. That's why we'll write rupees 1000.